Well, to sum up, we really believe that many benefits would accrue to our community if we avoid investing in additional fossil fuel infrastructure and instead focus in on retrofitting our current building stock, which is considerable, and starting to build differently with that combination of smarter building design and ground source heat pumps and renewable electricity sources. We think that overall these benefits will lead to a much more resilient local economy. The housing will be more affordable to live in because energy prices will be lower, and the residents in those buildings will be buffered from those price spikes. That means that those households will retain more income to hopefully be spent locally instead of exporting it outside of the county, to the coal, gas, or oil industries. We also predict that there will be a strong return on investment to developers, to the building sector, working on these buildings. And we find that overall there will be more job creation because this doesn't prevent entrepreneurs from expanding their businesses and creating job growth in Tompkins County. It allows that, but it also will result in more jobs in the building sector involved in this smarter design and in the renewable energy industry. And you may have been reading headlines about Solar Tompkins, for example, and the large number of new jobs that were created just in the past year from that initiative. So I think the case can be made for that. And importantly, I think that we can still support economic development while making progress on our climate goals, because making progress on those goals, that has a big economic sticker attached to it if we fail to make progress on ramping back down from rapid climate disruption. We all know that there are some considerable expenses we're already experiencing and anticipating more of them. So we don't feel that we're going to have to choose between jobs and ecosystem health. There's this clear way forward where we can be working on both of those essential needs, because if either one of those needs don't get met, we face a system collapse. So this is the problem that needs to be solved. Tompkins County is at a crossroads right now. As I said earlier, we have a proposed pipeline that if we build to use it up, we'll just make it extremely difficult, if not impossible, to pursue the emission reduction goals, because it locks us into that dependency on more fossil fuel use. We think the way forward is with smart design and renewably sourced electricity. So I want to open it up to your questions, and also sharing those of you in the room who are already using heat pumps in your practice and in your design work. We'd love to hear about your experiences with those. For example, Paul, I know.
Question from Brice. If you want to install a ground source system, you can bury your pipes horizontally or go vertically. Could you just talk about, first of all, how deep do you have to go for a horizontal installation, and what's the cost versus the benefit from those two methods?
So a typical trench is in the neighborhood of 6 to 8 feet underground for the pipes. It depends on exactly the nature of how many pipes you want to put into the ground and how much heat you're going to try to extract. And then the vertical wells, those are usually somewhere between 300 and 400 feet deep when they're drilled. They can go deeper, but they tend not to be more than anything else, just because if you drill them not straight, you might hit the next well over as you're trying to drill down and reduce the volume. In either case, the big question is, what's the volume of earth from which you're trying to extract the heat? If you're using the trenches, you generally need more feet of pipe per ton of heating capacity. simply because near that, in that top 6 to 8 feet, you're not down deep enough to keep it at a steady 50 degrees all year round. So as the heating season goes through, that ground might begin to cool to 40 degrees, depending on how deep you go. The advantage is, of course, that it's generally cheaper to trench than it is to drill. So if you can, the trenches are going to be a somewhat cheaper option. When you hit bedrock going down, if you hit it too shallow, if you don't have those top 6 feet, so for instance, I know at Village Solars, they don't have that much topsoil generally to go down. So there you're looking at drilling into the ground. The size of the drill is going to depend on the geology. Are you drilling through shale or unconsolidated deposits? But it generally will be somewhat shorter than the trench field in terms of the total number of feet that you have to put in. The exact costs are really site dependent, and so I wouldn't hazard a general number on that.
Just add that most horizontal distributions use what's called a helical loop, which is, you think of a slinky, and you lie it down and then you let it slide over, so they're all parallel circles. And the ones that I've seen are generally 12 to 14 feet deep. I think they're a little deeper than 6 to 8.
The slinky coils can be somewhat deeper, but people have put them in shallower. The slinky coil is putting a lot more feet of pipe in the trench, and so that would be one argument for making them deeper if you could, because it gives you a larger volume of soil and a steadier heat to draw them from. Others are simple kind of down and back systems where there's just 3 runs of pipe at the bottom of your trench.
A comment and a question. The comment is that the depth that you can drill for vertical wells really depends a lot on what you're drilling into. For example, in downtown Ithaca, there are places where you can't go much below a couple hundred feet. And what that means is then you have to drill more wells to get the same amount of heating and cooling, which has a big effect on price. And apropos to that, early on, when you were talking, I think about the residential construction, you were talking about the additional cost to put in a ground source HVAC system. Were you basing that delta on the equipment, or did you actually have the drilling costs in there? If you say the latter, then it's going to make me feel really bad.
It was the latter. It's the full life cycle costs. Those are net though of what it would cost you to put in the extra installations and the heat pumps and the well field, minus what you don't have to put in because of the natural gas system and the larger ductwork and those kinds of pieces. So that's not the raw cost, it's the net difference between what you would have put in if you built a system for the business as usual envelope and what you could put in with the smarter envelope, the smaller heating systems.
Speaking of all those costs, you've tracked so many aspects of cost in so many ways, but I didn't hear any mention of the cost of the pipeline. Isn't that something in the order of $15 million to be paid by somebody? And that was not included in your economic analysis, right?
Right. In one of Gabe's slides, it simply mentioned that there is this cost of around $14 million for the pipeline itself. As much as possible, we kept all of those kind of costs out of our analysis to show even if you are the most conservative possible, it still makes good sense. But that is because it's a reinforcement project, and what that means is they argue that pipeline is needed to meet existing customer demand, not just new customer demand, that therefore that $14 million is going to be recovered through the ratepayers, so through everyone who gets NYSEG gas in our area.
But that goes to one of your last slides when you talked about the savings of the homeowners who would then have that money to spend in the local economy. Well, this is a guaranteed $15 million coming from the ratepayers that won't have that money to spend in the local economy.
Right. No, exactly, and that money would be distributed throughout the entire economy of our region.
I have a quick question. You talk about installing these heat pumps under existing parking lots and areas like that, which I think is a great use of space. To begin with, I mean, if the parking lot's already there, how difficult is it, this trenching and stuff, if you're going underneath the existing concrete or whatever cement that is laid out? Is that kind of additional cost? I mean, if these buildings are already there and then you want to implement the heat pump and that's there, are you going underneath the side of it? Do you have to take the parking lot up and re-pour that?
If you're going to go directly under the parking lots the way we did, that we ripped them out. That for us, it wasn't a terribly large additional cost because the construction vehicles tear up our parking lots anyway. So we generally we would have to repave them after any major construction, regardless. So they just planned it that way, that the part that they were going to park all their equipment and tear it up anyway was where we put the well field. But yeah, you would generally rip them up because it's going to be a lot cheaper for you to re-pour that concrete than to try to trench little setbacks through it.
One of the biggest obstacles I see is the higher upfront costs and the lack of banks to consider the operating costs when they're approving you for a loan. Has there been anything done to start to convince banks that they need to look at operating costs in addition to just the initial construction cost, so we can get some of these higher upfront costs approved?
There are, and I can see some people will add on to this piece. What I would say is a couple of pieces. One is it's not a guarantee that you have to have the higher upfront costs. That if you can bake some of these efficiencies directly into the process, there are examples of where you can build for comparable or even less cost. Even locally, the cost of some of the eco-village expansions were done at a square foot cost that was less than some other conventional constructions of similar nature. In terms of banks and how they look at financing commercial spaces, they actually have a somewhat easier time of convincing them to look at some of these energy savings down the road if you're going to hold on to the building for a while, because the banks are valuing the value of a commercial space based on what your net incoming revenue per year is. And so if you're, as the building owner, going to be paying those energy costs, that reduction is actually going to show up in some of their valuation models. But it's not enough. Banks are beginning to look at this in a lot more detail. For residential spaces, there are actual programs already ongoing in our area. There's something called the Home Energy Rating and Disclosure Project. 5 towns in our area are looking at ways that you can standardize an energy audit and disclosure when you sell residential homes, so that when you buy them, you know what it's going to cost you to operate, and you can then begin to internalize some of those cost savings in the actual value of the home, and you can begin to see it recouped in the cost of homes. Also, so you can track it. Right now on realtor websites, there's no real way to know if it has high efficiency walls or sometimes even heat pumps or other things. Solar, even if you can only see it sometimes, do you know it actually is there? So some of those tracking metrics in other communities, they have found that to be really valuable because then the realtors know about it, and then it can be tracked, and it actually starts to show up in the value of homes, which is what banks care a great deal about. And so I think that there are the beginnings of a lot of this. Banks, 5-6 years ago in the solar space were very limited in what they could offer you. And as they've become more comfortable with that technology, it's really expanded in the solar world an awful lot. We would expect the same kind of thing would happen in the home energy if you could make it visible. Solar is somewhat more visible than some of these other pieces. Right.
Yeah, well, I'll just say that New York State is really aware of that as an issue and is instituting a bunch of new policies and pots of money to help with this problem, both for building of new technologies like this and retrofits. It's a huge problem. 85% of what's going to need to be done or more is retrofits of old buildings to achieve the kinds of goals they were talking about at the state and that we talk about in Tompkins County and just reaffirmed in the comp plan. One thing that Tompkins County is doing is we're in intensive talks with this program that New York State helped start and get going called Energize New York. It's a variant of their PACE program they were talking about before, where your upfront costs can be carried around over over the lifetime of your energy improvements. So rather than fund them over 15 years, you're funding them over the 30 or 40 years that the pieces of the system will last. And we're two banks. I think Citi was the big one, and another one. Maybe it's Chase. I can't remember.
Bank of America.
Bank of America. They're putting up $30 million. It'll be low interest financing available. They'll be stringent, debt ratio. They're not just making these loans to anybody who starts up. You have to have been around for a little while. But the loan will be low interest. It'll carry along with the lifetime of the project on your tax bill. And it won't be taxes, but it'll be paid off through the county or the city, and it'll be backed by if you default, it's backed by the county taxpayers and the city taxpayers. So we're just
PACE
putting a
financing
finish
stands
in.
for property assessed clean energy financing.
Yes, so we're sort of, that's a local law, so it'll take a few months, and if people have strong feelings about it, they should come out and watch me over the next few months. We'll be doing that. We are talking about, can we make countywide the example you just gave of requiring energy audits at point of sale on all properties. So we've got a package of things that we're talking about doing that are both keeping people accountable but also providing support. And then New York State is involved in this reforming the energy vision, where they are really pushing, or will be pushing, smart grids, requiring new infrastructure to be put in. They've already said, we know we can't keep building peaker plants that require 3 times the amount of power for the peak, those 50 or 60 peak days or hours of the year that are used at average, and you're going to be left
the rev is
behind.
mainly around electricity, so
Well,
it has
but
its
you're gonna-
feedbacks into
But
the
you're going to be
energy
left
system.
behind. If you're putting in old systems, by 10 years from now, your systems, the people moving into your buildings will feel like you've been left behind, and why should they have to pay for utility costs?
So
and
the
higher-
piggyback question here is, there's the perception that to put in this green energy technology, it's going to cost more upfront, whether it does or not. So one thing that would be very helpful for us designers would be if there's maybe a canned presentation that we can use to present to a prospective client or an existing client that says, here, this isn't something that I made up. This is coming from New York State or Tompkins County or whatever that shows, look, we can do this for the same price or even less price, and your operating costs are going to be even less. Having a tool like that for all of us designers to use to help convince people that, hey, it's really not going to cost more to use these new technologies would be extremely helpful.
Yeah, I mean, that's your department. I'm taking notes on other possible.
And even when there are small cost premiums, I think there's still a good argument that can be made.
So I'm with an affordable housing developer. We just built a 50-unit apartment building 2 blocks away from here that is heated and cooled by an air source system. And I think you made a really excellent point, is you have to convince people. So in our case, we had to convince our funders, which is how affordable housing gets built, you get subsidies, that this made sense over the long term. And the interesting part of this was that their point of view was compared, you're going to save money, but compared to what? So the main convincing that we had to do was that to pay more money up front, and it did cost more. And their perspective was an affordable housing project built in a cornfield that's a 2-story wood frame building that isn't energy efficient. How much does it cost to build that versus how much do you want to spend on this? And that was the whole discussion. And it took us 2 years to convince them, but eventually they were. And I also want to point about lenders is that the whole, if you could summarize loan underwriting, it's an analysis of, do you have enough income to support the loan payments? So you have to demonstrate that the savings that you achieve from energy efficiency is producing more cash flow, and that will justify the cost. And I don't think that's a hard argument to make.
It's not, as long as they're willing to accept the fact that, hey, there is going to be energy savings, and we are going to be paying less in utility bills. But in my experience, it's been difficult to convince them that the energy bills really are going to be less.
And it's one of the things that in the last few years we've really seen an expansion of the data-driven, sort of performance questions. That right now a lot of what has been done is done on these prescriptive models where you're modeling energy use and you're really comparing, what is the energy savings and cost of one sheet versus 2 sheets of insulation. And there hasn't been a lot of need to try to true those up to real building energy performance, and so that's led to a lot of questions around what the real energy savings are for the whole kind of package of systems. There are a lot of companies now in a lot of states that are moving towards these monitored systems where you have 10 or 15,000 commercial buildings, and you're actually looking at their monthly utility bills pre and post, and you're actually kind of modeling their energy use and really getting a body of evidence around what are the true energy savings. And I think that's going to help move this discussion along quite a bit. All of this, of course, is the carrot. There's also the stick that I think needs to be addressed, which is the building code. That the building codes can be much more, much tighter than they are currently, and that would sort of help to incentivize this. There are certain things that we should be doing just because they really do make sense. They don't add a lot of cost and they make a lot of energy savings. So those should just be built into the code. And so going to the most recent energy code, we'll see how those discussions shake out in New York. But I do also think there's a lot that local communities can do around their own building codes, their own zoning structures. And then even things that don't cost anything. So one of the sort of simple ideas is when someone comes to apply for a building permit, you give them a package that explains all of the technologies that they could be looking at and what are all of the cost savings that you get from them, and then what are all the tax incentives and other kind of rebates that you might be eligible for, so that you make it really easy for the people who are actually doing these kind of retrofits to say, wait a minute, maybe I should be looking at some of these other pieces. So I think there's a lot to that question, but you're getting at the split incentive between the builder and the user of energy. But there are ways to move forward on
that. That packet you're talking about would be helpful for the designers as well as, because it makes us not look so intelligent when we design a building, maybe not knowing some of these latest technologies, and then the homeowner goes to apply for the building permit and they get this packet of information. Hey, you could be doing this and this and this. And then they come back to us and say, well, why aren't we doing this? So having that for the designers as well as the homeowners would be extremely valuable.
I know we're short on time, but maybe just one last question.
The last time I sat through your presentation, I asked a question about the glycol that you're pumping into the water source. So I put a lot of thought into that instead of reiterating. The question I asked the last time was, everybody in Tompkins County hates the word fracking because you're going to ruin the water table. Well, you're directly pumping glycol now into a system that eventually will fail, will leak. This will definitely go right directly into the water system. So I put a lot of thought into this since then, and I think that you could totally avoid pumping any chemicals at all into the ground if you used a plate exchanger, heat exchanger system with a heated mechanical room, and you could pump direct, just plain water into your ground source and use a plate heat exchanger and then take your glycol source into your house. That way any leaks that would be on the surface, you'd be able to see those. Anything that will eventually fail that's in the ground will only be leaking fresh water into the ground. You'd never contaminate your water systems that way. I don't know if anybody in this room has ever put any thought into that or not, but I think that pumping chemicals into the ground, into the water table, which is where we're directly trying to hit here, 400 foot in the ground, that's a really bad idea. I think we should definitely look at somehow to keep this clean for my grandchildren, for everybody's grandchildren.
And so just the quick follow-up on that is the water that you're using in these systems, it is a closed loop system, so it's not a direct injection. There were ground source systems that were injecting into the groundwater and then withdrawing from it. But this is a closed loop system, so the piping and the casing and the cementing of the wells would all have to fail for it to leak. The glycol is food grade glycol, so it's the same thing that's in ketchup and the other kinds of things you're going to get. And that SUNY Cortland system, the entire system as a whole, contains about 30 gallons of glycol in the entire system. And so the amount that's in the ground at any given time is a tiny fraction of that. So it is a very small amount of a material that's in the ground. But there are designs if you want to avoid those that use other fluids or less glycol in the ground, which that they do exist. So we're getting that kind of design here. So great. We'll stick around if you have other questions.
Yes, we have to be done and out of here by 3:30, so we want to give the camera crew a chance to pack up their gear. But we will be having a video of this presentation, and we will be sending it back out to all of you with a link to the Vimeo channel that we'll put it on, so that from there, we're hoping that you will share it with a lot of your colleagues. It's maybe not exactly the package that you were looking for, but it's today's package, and hopefully that will be of use to a number of other people in the community. In terms of this conversation about can we make this transition without further expanding our dependency on fossil fuels? Can we make it through this decision point together? And I truly think that we can. We've got a lot of fine architects and builders and developers in our community, so I think we can do this. Thank you so much for your participation today. I'm glad that you could join us. And thank you to Brice and Melissa as well. Thanks.
Okay, bud, I'm in a meeting with that. Huh?